So hello friends, welcome to the live stream. Today I will render an X-Wing on the emulator from David Mary's, the 8-bit guy's Commander X16. For those who don't know, the Commander X16 is a new 8-bit computer which is done with modern parts, and the goal is to build a computer which gives the feeling of the past from the 80s with modern technology. So maybe some of you may know I wrote a 3D renderer for the Commodore Plus 4, and the renderer is written in BASIC, and the Commander X16 BASIC is very similar to the BASIC of the Commodore Plus 4, Commodore 3.5 BASIC. And I went into the effort to port this code onto the Commander X16. And let's find out how the render will look at the end. So first of all, I have to copy the code into the Commander. Nice name, by the way, Commander. So this is the code. Copy and paste into the emulator. I make a direct stream from the window of the emulator, and now you can see that the emulator, the emulator has started by its own and loads the vertices into the memory. Okay, so let me check a few things here. So in the first pass, in the first phase, the emulator loads the vertices. And now we have a few options here. We can rotate the model. The model is displayed in dots and points here. This has performance reasons. And we have the three axes here. This is the y-axis, the x-axis, and in the depth you can imagine this line here. This is the z-axis. And now I press the key by accident. So this is real time. This is not speeded up. The Commander X16 runs on 8 MHz, which is about 8 times faster than a Commodore Plus 4 or a Commodore 64 or even a Commodore VIC-20. So you can hear, if I press the Y key, okay, I have the German keyboard, so I have to press the Z key for the Y. So if I press the Y key, I can rotate the model, and this is the axis. Over this axis I can rotate it. When I put here, let's say 180, then we will have, I guess, the front view of the X-Wing. And that's the case. You see here, I hope you can imagine this. Imagine an X-Wing, and this is the front view. This is the nose, and these are the wings. You see, it takes a while but that's a part of the fun. Slow things a little down to see how the program works. So the front view is a little boring. We will go again to the quarter view, or how it's called, and we will zoom the model a little in so that it fills nicely the screen. So I hope you can imagine this. This is the nose here, and here we have the 4 wings of an X-Wing. An X-Wing on a Commander X16. Okay, if you see this exclamation mark, then the pass is finished. So I built in a zoom function. First we will center the model with the N key. So it passes all the vertices here, the 1083 vertices, and finds the and tries to position the model in that way that the spaces here are equal. Okay, so it draws it again. So when this is drawn, we will zoom the model in so that fills out the screen. The Commander X16 has a screen resolution of 320 horizontal per 240. These are 40 pixels more than a Commodore Plus 4 and 64. So okay, now we press the auto zoom here. And you can see here the model fills out the screen a little better. And in a moment I will start the render. So it's nice. It's very nice to work with this computer. It's fast enough, I think. So we press L. So in this phase, the program tries to find the visible faces. Visible faces is the faces that we can see. This model contains of polygons, also called faces. And in this case, the polygons are not triangles. Normally, if you have a modern 3D engine, every model is put together of triangles because you can calculate better with triangles. But in this small resolution that the Commander X16 has, or let's say the Commodore Plus 4, which is the platform that I originally wrote the engine. If we make every face of triangles, the model, the end result will look too meshy, too many lines on this small resolution. You can see here how thick a line here is. This is 1 pixel, by the way. So now the program has found the visible faces, 307 of 1000 and a few, I think 1036 or so. And now we will sort all found faces, all found visible faces, in Z order. Z order means we will sort them from the back to the beginning. What this means, we will see in a moment. This is called the painter's algorithm. And painters, because every painter, if he wants to try to paint a landscape, he first starts with the background, and then layer by layer he adds the objects which are closer to the viewer. And this is exactly what this program does. Now that we have found the visible faces, he tries to paint the polygons which are the farthest away. These are the engines here. There's a part of the wing, and works its way to the front. With a little imagination, you can follow the process. It's a little, I know it's a little difficult when you see this the first time, but it's not impossible. So well, this is a live stream, so if I make mistakes in my talking here, pronunciations, I'm not a native English speaker, but I try my best because I love the English language. I speak 3 languages. I speak Greek, Kalimera, Kalispera, Servus. I speak German. Guten Abend an alle. Willkommen zu meinem Livestream. And I speak, try to speak English, the international language. Hello friends, welcome to my livestream. So, the beauty of this program is that you can literally see how this works. And many people ask me, not many, a few, why don't you write this code in assembly? And my answer is, and I've said this in some of my videos, my answer is simply because I like programming in BASIC. I'm not good in assembly. And writing the program BASIC, originally on the Commodore Plus 4, enables me now to port the program to the Commander X16 and to future machines, basic machines, which are popping out lately, like the, let me think, was one from England, Acorn? No. Something with A. Or many others here, Raspberry Pis. Even the PlayStation 2 has a basic program because they tried back in the day to market the machine, the PlayStation 2, as home computer to pay lower taxes. So the render is finished now, and it came out really well. See, that's yeah, here you can see why I've chosen polygons, mainly here these polygons with 4 edges and with 4 vertices. Because if this were triangles, we had here additional lines, and the model wouldn't look as good as now, I think. I've chosen a very low poly model because the difference to the Commodore Plus 4 is that the Commander X16 has half of the memory free for BASIC. That is about 30 kilobytes, and the Commodore Plus 4 has 60 kilobytes free memory, and which makes the Commodore Plus 4 BASIC very cool and very good, in my opinion. So I hope you like this here. We can go through the code if you want, if you like. I know nobody is watching, but maybe Oh, one is watching. Hi there. Hi. Okay. I hope you can understand me. This is very improvised. Okay, let's go further. Okay, so this is the X-Wing with about 1000 vertices, and I said this is a very low poly model because we have to find a balance between the screen resolution, which is 320 per 240 on the Commander X16, and if you choose a too meshy model, the result will not look very good. Too meshy, too many lines. We can go stop the program and go through the listing. Okay, we have a memory overflow here. Let's see, new. Okay, so okay, how can I clear the screen? Let's restart. Okay. Maybe we can, okay, CLS, list, that's, okay, maybe a bug in the emulator? I don't know. Okay, there are about 300 lines of code. Stop. Okay, let me try something different here now. Okay. So this is the code, very ugly code and basic. You can hear we have the line numbers. Oh, okay. So the editor, okay, good. We can do following list until, let's say, how many lines? 250. Oh, that's I think. Why I have here syntax error? I don't know. Let's try again. Never give up. Okay, list until 500. Maybe a little too much. Okay. I don't know why. I can imagine that this RAM statement here, I will delete the RAM key. Okay, we will make it another. Okay, copy. So let's try another thing. So new CLS, clear the screen, and now I pasted it directly from the editor. So here you can see the line numbers. So you can, okay. 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 Screen mode 80. Here is hex 80. Means that we go into the iris mode. You can set here the colors. 5 is here green. CLS stands for clear the screen. Very similar to the Commodore basics. I don't know if the Commodore 64 has these commands here. Color definitely not. But the Commodore Plus 4 has a similar command. And here the goes up is initialization where I clear the screen and make it black, because if you set the color and clear the screen, let's say you set the color, the background color black, and when the Commander X16 starts with a blue screen, and you make a CLS here, the background turns not black, so you have to draw lines here, every line, and with black color, so that you get a black screen. Here are some variables for initialization. These are the initial variable degrees. 10 degrees on the x-axis, 10 degrees on the y-axis, and 10 degrees on the z-axis. And you have here, this is a variable for the pi, a pi constant, 3.1.11415, and so on. So, but this is here the interesting part. This here. So why I deleted the spaces? It's very simple. You can the code and the model data share the same memory, and the code is written in ASCII characters, and every ASCII character needs 1 byte. Even the spaces here. And if you make the code compact, you save a little space, not much, but a little space for the model data. Little. Okay. I know. So how can we read sequential files? Sequential files are basically text files. Sequential files are files on a physical media. Let's say this floppy drive or disk drive. And if you open this file with a text editor, and the file contains only numbers, you can read it. So this line here, line 60, this is how it's done. How you the procedure is: you open the file. The file has the name vertex.seq for sequential, and then, because there are many file types, you have binary files, you have sequential files. This is sequential. You tell the command here open that we want to open a sequential file with the name vertex point sequential type and then read or write. We want to read it. We don't want to write in the sequential file, we want to read it. And which took a little to find out how to do it on the Commander X16 is this 2,8,2. And this is a little different on the Commodore Plus 4, where you usually I think it's 8,1,8. I can look it up. I hope I find it. But doesn't matter. It's different. And it was not documented in the early emulators, and it didn't work from the mounted directory. You had to have an SD image, and well, you had to have an SD image, and you this was not documented in the first emulators. But I found it out in the forums, and this is how it's done. So this input is like a read command. We have this input and then this sharp character. With the 2, we opened, I think, this logical drive 2, and then you can, it's in the sequential file contains comma separated values. Each line has 4 numbers, comma separated. So if you open the file, we read the first line and write the numbers into the variables C, D, H, and U. So we read the first line and write read the first 4 numbers in the line, which are comma separated, and write them. Let me see. We use the U for dimension the arrays here. Dim is a dimension. We dim U. Let me see if I can. Yes. So dim U and dim SL. These are, I know, well, I guess if you're watching this video, you already know about BASIC. But with dim U, you can initialize arrays. You can say, I want an array. Oh, I think I have forgotten here. Dim U. I've forgotten the U. Oh, I deleted it. So, U. So I have an array with a name U, and this has, let's say, I dimension it with the value of U. Let's say if U is 100, then I have an array with a length of 100. And SL the same. We unfortunately, this type of BASIC, this old BASIC, doesn't have dynamic arrays, or you cannot redimension the arrays during the while the program is running. So you have to define the fixed length at the beginning. If you don't do this, you can run into overflows. So this is X, and this character here, I don't know how it's called in English. Percent, yes. Percent, I think, are integers, and if you don't have this percent, it defines the value type of the values which are held in the array. No? And X, Y, and Z, I think this integer, all coordinates are integer values. So integer has, I think, 2 bytes. maybe I'm wrong, I don't know. And if you have real comma separated real numbers, then you waste 5 bytes. So this is done to save memory. And as you can see here, I dimensioned here some arrays here at the beginning. And this here runs in a loop. The first line is the first line of the sequential file as the information for the dimensioning, for initialization of the arrays. And then the following lines, you can see here, I go here into a for loop, into a loop. Okay. So here I close. Well, I go in the for loop and I know how many lines I have. C, no? C is read here at the first line of the sequential file. So I go the steps here from 1 to C and make another input. And you can see here I reference here the array, and these are the vertices of the model. X vertex, X coordinate, the X part of the coordinate from vertex A. A runs from 1 to C. Let's say A is 1. The first vertex, the first vertex, which is a tuple of values. So let's say tuple in English is a vector of 3 components, X part, Y part, and Z part. And I load every vertex into the memory. I hold the vertices in the memory so that I can rotate, translate, zoom, and so on. Do all these operations within the computer. And let me see here. Okay, I won't go here through all the code. It's just some informations. Okay, here's the next part. If you have a for loop, you have to do next. Normally you say next A, but it's not necessary. And when you are finished with reading, you can close. You have to close the sequential file and you are done. You put data which was stored on physical media into the memory. And this is how it's done with sequential files in BASIC. Okay, so let me see if anybody is in the chat. Hi, Ellen. Okay, yes, I will answer you. Yes, it will replace Nile numbers with labels. It has an editor, which is new. David showed it in his last video. And this is a cool thing, because I wrote an editor myself years ago with the same functionality for the Commodore Plus 4. But not, it didn't run on the Commodore Plus 4. It was an external tool on PC. So that you have to deal with line numbers. Line numbers are really a pain in the, because you cannot program dynamically. So in the next, I port this program onto the Atari ST, and let's say the Omicron Basic, which is very cool. There you can program with line numbers, but you don't have to. No. Same with the other basic, GF Basic. I forgot, it's late here. It's about midnight here, so I cannot think clearly. Yes, you are right. Okay, so let's go again to the... Okay. So if you want, I can go further. I'll pause the next part of the code. This a little basic programming. Why not? Okay, that was a little too much. So let's do it like this. Copy. So let me try this out. Okay. This to 120. Okay, well, it's not very readable here on the Commander X16. What this does here, okay, well, I will do another trick here, at least. So stay with me, continues. So this is the menu part, the part where I press the keys and you could change the degree, the angles. And on the Commander X16, you have to make this endless, this loop, this go-to loop. You call this function here, get a string, which reads the last pressed key. So if I press X and the program is at this position here, it will write an X in this a string. This is a string variable. The dollar sign marks the variable as a string, so this will have an X. And if I haven't pressed, so you can you have to read this like this here. And we have here go to 220, which is the same line. And if I don't press a key, so when I don't press a key, the variable is empty. When this thing is empty, then I go to the beginning of the line. So I'm in a endless, in an it's in a loop which never ends. Okay, so the moment I press a key, I don't this condition here doesn't apply, and I can go further, 230. So if this is an X, then do this. If the A string is an X, then go to the subroutine at the line 3200, which is, I think, I position the cursor at the top, and then I print this here, the angle X, angle axis, which means make an input of the angle of the X coordinate, angle on the X plane. Well, I can demonstrate it. Okay, new. So we will copy the program. Very basic stuff, but I think if you're in the same age like me, you have fun at these things here. So this is the loading part, which I showed before. The sequential file holds 1083 vertices. So it draws the vertices. And I can interrupt this if I want. I press the X key. Well, I let it run through until we see the exclamation mark. Okay, so angle X. This is what I showed, and now I can I think 10 degrees. Okay, this will tilt the model in this direction here, in this direction. So this is tilted down 10 degrees. I will put it at 90 degrees. So the X-wing will face down. You can see it. Well, here's the nose. Here are the wings. Here's the engines. So you have to have a little imagination when you use this program. But I think that's a cool part of it. It's not a streamlined computer. It uses it's written on the edge what you can barely do on this thing, and this is the most fun for me. Okay, so if I put it on, so let's see the let's put the X coordinate again to 10. Let's put it to 0. Let's play a little around. So that's now the tilt of the body is 0 degrees. Here you have the nose. We have here an angle of, I think, 190. And here the wings. Now we can position the X-wing so that it faces towards us. I will okay, y-axis is here, 195. When I put 180, the nose will be here at the middle. Okay. So now the X-wing flies towards us here, and I can make okay, let's make following. I will put the X coordinate to 90 degree to so yes. I don't know if this is the bottom or the upper part, but we will find out when we render the model. So let us first go a little down with the zoom. So let's go, this is zoom, M key. Let's go a little down. Okay. So the pixels, the last pixels are not over the edge here. Yeah, that's good. fills out the screen, and let's render it, and let's see what's the result. Okay, program runs. Let's take a look at the chat. Okay. Oh, second or three. I don't know how many people are watching. 2 or 3. I will give an hi on the chat. Hello everybody. Thank you for joining. Okay, I see we have a delay here. Oh, we have a quite heavy delay here. Okay. Okay. I see at the first glance that we have a small error. Some faces are not recognized as visible. But anyway, it's this program is programmed for fun. And first, it's programmed for fun. Second, it's programmed because it's a challenge. And third, it's programmed because I was in a lockdown in the pandemic. And this project here was always a dream of mine, because in the 80s I was watching the TV show Battlestar Galactica. Many of you will remember it. And they had this cool green wireframe graphics, which I tried to replicate back then on my Commodore Plus 4. And that's why these are green. No? And the lines are green, because I really like that graphics which were done on a Tektronix. And there is a another YouTuber, Monty McGraw. Monty McGraw? Yes, I think. Who has a channel, Monty McGraw, I think it's the name, where he does demonstrations on his Tektronix, which were basic machines like this here, but very, very expensive. And the memory, the graphics memory, was the tube on these machines. It had a tube storage memory, something like that, so that it didn't have the machine, the Tektronix doesn't have screen memory, but when you draw a line on the screen stores the line. It has a layer of phosphor, and now here you can see what I mean. So this is the bottom, as it seems. Yes, this is the bottom. And I don't know why we have a bug. It should have recognized this face here. Okay, now it throws the second pair of wings. Very cool. Very cool. We will make different angles today, if you like, of course. So, oh, finished. Okay, you can see here the the renderer is not perfect. I forgot this line here for whatever reason. Now we will make a side view. So I think the bug might be when you run the renders a second or third time that this results in a bug, but I'm not sure, and I have no time at the moment to debug it. But let's do another view, a side view. Let's do a side view. Okay, so we put the y coordinate to 90. So we not 90. We put the x coordinate to 0. Well, let's do 90. Well, the x coordinate to 0. So now we have the side view. Okay. So here's the nose. Here's the top of the X-wing. Other top, here are the engines, and this must be the cockpit here. Let's render. Let's see. Yep. As I said, maybe we have another bug, but it's okay. No, there is no software without bugs. I can say this from my own experience because my profession is a programmer, a software developer, which I am doing for about 35 years or so. And I've done a lot of projects, and I can definitely say no software is without bugs. It's only the thing has to be that the software has to fulfill the needs of the users. Okay, now it draws the up, and we have a quantity error. Okay, so let us read the values first. 160. Okay. Okay. Oh, this is not very fast. List 2 until 100. So I need this values here: gx, gy, gz. Comma gy, comma gz. Okay, 0, 90, 180. Okay, let's try it again. We make a new, we reset the memory, and so there is a possibility that if we run the renderer a few times, that we get an overflow. So I like to restart the program. And the cool thing is that this is an 8 MHz machine. And you can do this in real time without putting the emulator in warp mode, like I usually do on the Commodore Plus 4. It's fast enough. Okay, let's wait until the vertices are loaded. Okay. X was 0. Y were 90. And the others one, okay. Okay. Maybe. Okay, let's put the zoom factor a little down. 14. Yes, that's yes. I think that was a problem. What I think is that if you draw lines and the coordinates are out of the screen area, we get an overflow error. So I will go. I can't see now here where the screen ends. Well, I guess here. I don't know. Well, I will put the scaling a little down again. Doesn't matter. So that we are on the safe side. On the Commodore Plus 4, if you draw a line and let's say you can put the coordinates, the maximum is 319, and if you set the Y coordinate to 350, let's say, it won't get an error. But on this machine, you will get an error. Now, and this is, I think, why we jumped out the program. That's my theory. I don't know, but I ported the program, by the way, on several systems. Well, VIC-20, Plus 4, Commodore 64, Amstrad CPC, DOS, QBasic, Atari ST, in two different basic dialects. So the one was GF Basic and the other was Omicron Basic. Then Amiga, Amos, some exotic, Apple 2, and Apple Macintosh. Macintosh was very difficult because it had a buggy compiler, a buggy interpreter, basic interpreter from Microsoft. And some other exotic which I can't remember yet. I have to do a list. I have to do a list and make a repository somewhere, GitHub, so that other people can enjoy this program too, if they're interested, of course. So the program ran through. As I said, the zoom factor was too high, so that if when the basic here draws a line, you go into an overflow. And some basic dialects have no problem with it, but in this case we have a problem. And this is a nice side view. So, friends, late here I have 3 viewers too. Very nice. So that's very nice, because it's cool that I wasn't talking to myself only. And I don't know if this if the speech here is synchronous with you or with a delay. I guess with a delay. So, well, I will put so any questions? Maybe any questions? Well, I can see my video here, but with a delay, heavy delay, maybe 1 minute or so. So, well, I guess nobody's listening here. Okay, let's do a nice let's do for at last action here a nice view. Okay, put the x-angle to -10. And the y-coordinate, okay, this is 90. We put it to 60. So this will rotate the nose in this direction to the back. Okay, let's see. So that we will see the spacecraft from the back. Ah, nice angle. Yeah, why not? Why not? Okay. I think this is a good, we can rotate it a little further in this direction. Let's say 50. So that you can see a little more of the back. Okay, now I will start the auto center function. I hope there's no bug. So that will have the effect that the model is drawn in the center here. I know it takes a little while, but I have fun with it. I like spending my time on these old machines doing 3D graphics. Oh, okay. It centered the model. So we can also try the experimental function to scale it in that way that we have the maximum size here, which fills out the screen. That's okay. Let's try it. Why not? Okay, 20. Okay, but I will go the safe way. I will go on. I will go 19 to be safe. Otherwise, we could run into an exception again, into an overflow, and that would be not so nice. Okay, I'm looking forward to it. Okay. So it tries to find the faces, the visible faces. Maybe you can recognize it. Here's the nose. Here we have the upper wing, down wing, left wing, right wing, and here are the engines. And here's the cockpit. Okay. So let's hope that we don't run in an overflow here, because it does matter the amount of faces which are found. But we are lucky. So this means 273 visible faces of 1000 and something faces overall were found. Now it's sorted. Sort algorithm is shell sort. Yes, shell sort. First I used bubble sort, and that took many minutes, maybe in half an hour, to sort all the faces. Because you sort 3 arrays here per coordinate, per component of the vector. So you have an array for the x coordinate, for the y, and for the z part of each coordinate, 3D coordinate. Well, I plan a video, if you are interested, to go through the engine to demonstrate what the theory is behind the this painter's algorithm. And if you like, I will make a poll also if there is an interest in it. Oh, it's late, yeah. You know, the basic of the Commodore, of the Commander and the Commodore Plus 4 has not a polygon function, which means that you can put the coordinates and basic draws your function. So you have to write your own polygon function. And in this case, I had to write a polygon function which fills out the faces. This is not flat fill here. This goes really, if you draw a polygon here, like this here, you have to do a scan line procedure. So you draw first the polygon, and then you scan every line and blank. You draw a polygon with green, and then within the polygon you blank out. You fill out the space, no, with the lines. And that took a while to implement it in BASIC. Well, I had to find algorithms on the internet for C#, let's say, and the way I did it is I implemented the functions in C#, so that I know that they worked, and then I did it in BASIC. Oh, very nice. Looks really cool. Really better than I expected. Oh. The beauty of this program is that you can actually see how this works. If you want to take your time to watch this kind of things. So, that's our last render for today. I hope you liked the stream. Very spontaneous. And I'm missing 5 followers, I think, to complete the 500. And when I complete the 500, I will make a special celebration video as a thank you for the 500. So, friends, that's it. George here. And thank you for watching, as always. And thank you for your support. And have a nice day or a nice evening, like me here. And I wish you a nice time, and see you in the next one. Bye bye. Thank you. Thank you. Coffee Lizard, thank you. Well, this is a 3D engine programmed in BASIC on a 8-bit computer. And in this case, the Commander X16, which is coming out now. So, greetings to Coffee Lizard. He asked, what is this about here? Looks super cool. Well, it's a 3D renderer written in BASIC, running on a Commander X16. The original program was written on a Commodore Plus 4 from 1985. And this Commander X16 is also an 8-bit computer with the same processor, but made in this year, and I think it is already released this year. And made by the 8-bit guy, David Murray. So greetings to that team. Great computer. So bye-bye.